This video is going to be a quick overview of the difference between permutations and combinations. And these are both counting techniques, so we're using them to try and count the number of possible outcomes. But we're going to use them in two different situations. So to start off with here, anytime that you're trying to count the number of objects from a group of objects, and repetition is not allowed, so without repetition, then you're usually going to be choosing between permutations and combinations. So again, the important part here is that whether we use permutations or combinations, those are both techniques that are used when we are working without repetition. The difference then is going to be in whether or not the order that the items are placed in matters. So if the order matters, so the order that we select our items, then we're going to use permutations. And I always remember that because O and P are right next to each other in the alphabet. Okay. If the order that you're placing your objects in does not matter, then you're going to use combinations. So let's look at the definition here for permutations. It says if we're selecting our objects from a group of n items where no item may be selected more than once, so that's important, that's the without repetition part, and the order of arrangement matters, then you're dealing with permutations. And the formula for permutations looks like this. If we have n items and we want to take r of them at a time, we're going to use n factorial divided by the quantity n minus r factorial. We're actually going to be doing this using the calculator. So I'll show you what that means by hand, but we'll be using the calculator. So in the first example here for permutations, it says we have 13 players on a Little League baseball team. And we're asked how many ways can the coach form a 9-player batting order. This is a batting order, which means that the order the batters are placed in matters, right? It's a different order if we have a certain player go first versus if we have him go 7th or 8th, okay? Also, you can tell that this is without repetition because I can't have the same player in multiple positions of that 9-player batting order. So if we look at this and recognize based on those two factors that it's a permutation question, that means that we have 13 items and we want to permute them with 9 at a time. So the bigger number is always over here, and then we're placing that many of them. So we could do this by hand using the above formula. This would be 13 factorial divided by 13 minus 9 factorial, which is 13 factorial over 4 factorial. And factorial just means we multiply down by integer values until we get to 1. So 13, 12, 11, 10, 9, 8, 7, 6, 5, etc. I'm going to stop there because what you can see is as I would multiply by 4, by 3, by 2, by 1, in this denominator I also have times 4, times 3, times 2, times 1. So I'll try to squeeze those in, but what happens is those cancel. And I just have 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5. And I hope that what you can see is that's really similar to what we did before with the Social Security number problem. So if I have 9 positions in a batting order that I want to fill, I cannot have the same player fill more than one position. So for the first position, I can choose between 13 of the players. but by the second position, I've already used one, so I can only pick between 12. And you can see how that nicely lines up with what we would end up with using the permutation formula. What I want to show you is doing this using the calculator. So if you want to do permutations in the calculator, you're going to type in the larger number first. So we have 13. You're going to hit the math key along the left and use your arrows to arrow over to PRB, which stands for probability. We're selecting NPR for permutations, so hit enter. And then you enter your smaller number, 9 in this case, and hit enter. And we are given then 259,459,200 possible orders there. Okay, so that's an example with permutations. What we're going to move on to is an example with when we would use combinations. So with combinations, we still are looking at cases where we have repetition not allowed, so we can't duplicate individuals or objects in our positions, but the order that we place those objects in doesn't matter. And so if we do that, we're going to, instead of using permutations, we're going to use combinations. So you'll notice the change is we also are going to divide out by any duplicates. So that's this r factorial here is going to pick up any duplicates that we had. So we're going to divide out by those. So if I look at Arizona's the pick lottery system, it says we're going to pick 6 numbers between 1 and 44. And how many different lottery tickets are possible? Well, in the lottery ticket, you don't care what order you pick the numbers. Usually they just put them in numerical order, smallest to largest. But it doesn't matter what order the values get picked as long as your numbers match the winning numbers. And so this would be a case where we can't pick the same lottery number more than once, but the order that we pick the numbers in doesn't matter. And so this is a combinations question. We have numbers between 1 and 44, so we have 44 different items, and we want to take 6 of them. So this is a 44 combination 6. Again, we could do this by hand if we wanted to. This would be 44 factorial divided by 44 minus 6 factorial times 6 factorial. So I would have, in this denominator here, 44 minus 6 is 38. So everything from 38 on down would end up canceling. So I'm just going to have 44, 43, 42, 41, 40, 39. And again, I would continue going all the way down, right? 38, 37, 36, all the way down to 1. But when I'm dividing out here the 44 minus 6, which is the 38 factorial, everything from 38 on down is going to cancel. So I'm just going to write it that way. And then we still have the 6 factorial. Okay, so that's how you could figure that out if you wanted to by hand. We're again going to do it using the calculator. So we put in the larger number first and hit math, probability, and we choose 6. And we get 7,059,052. And then to finish this up, it asks us here for the probability that our ticket is the winning ticket. Well, there is only one combination of numbers that's the winning ticket out of 7,059,052 possible combinations. And so that gives you an idea how unlikely it is to win the lottery, right? So you got 1.4166 and some other numbers there, and then e to the -7. So this is times 10 to the -7th power. That's telling us this is such a tiny number, we would have to move this decimal place 7 places to the left. The negative means to the left. So we have 6 zeros, and then 14166. That's our probability of winning the lottery. Okay, so very, very tiny there. Okay.